Great stuff. Fantastic. Well, we'll get started. I don't think anyone who walks in a minute late is going to miss much. So first things first, a little bit about me. My name is Josh. I'm a Christian. I am a husband to my lovely wife. We have a dog and a Packers fandom that is hurting a little bit right now, but we're going to get them this weekend here. And I'm also a cybersecurity enthusiast. That's why I'm here, because you didn't really care what football team I rooted for, did you? Okay, about me as a professional, I work at John Deere, specifically our Intelligent Solutions group. That's the group that puts the software on the tractors, puts the software on the websites, and works with the tractors, all that sorts of stuff. I'm specifically part of the digital security initiative there, so I work with about 30, give or take, security products teams, 30 digital product teams, however you want to look at that. Just other stuff that I've done in the professional realm. I recently authored the Secure Cloud Architecture Cheat Sheet. It's a really long title for the OWASP Cheat Sheet series. You can find that. It's an open source thing. Really proud of that. I've also created a couple hack box challenges. Those are pretty fun. One of them is a really good rating. Don't ask about the other one. And then finally, I'm with the North Carolina Partnership for Cybersecurity Excellence. They have a booth down there. I was sitting down there earlier today. I was just trying to get folks within North Carolina aligned towards the same goal of being really strong in cybersecurity. So whether you're in the government, whether you are in industry, whether you are part of an educational group, we want everybody focused on strong cybersecurity. We want to make North Carolina a leader in that space. All right, before we get started, couple things to keep in mind, couple clarifiers, however you want to say it. I want to put your mind in the right state for what we're going to be talking about today. I am not an expert in the Juice Shop code base. Well, I guess first off, do folks know what the Juice Shop code base is? No? Okay, one knows, a couple of yeses. Okay, we'll talk a little bit more about it, but regardless, it's a thing, and I'm not an expert in it. So I might know a little bit more than you, because I'm the one giving the talk, but it's not like it's way out of the realm of possibilities for you to learn this stuff, for you to understand what's going on here, right? This is not some super mystical, incredible thing that's going on. I want this stuff to be accessible, and I want you to be able to see that it's really not a large lift to get there. A couple of things that I have experience in that will help me with this, and if you don't know some of this stuff, well, then this gives you an opportunity to kind of learn some of this stuff. Developed in multiple different languages and frameworks, professionally and personally. I have done secure code review in a professional setting, and I've found a number of vulnerabilities across a lot of different systems. That's very beneficial for this. And then I've also done some bug bounty penetration testing work. Okay, I think that this type of information is really valuable for developers specifically, because as you look through a code base, you want to be able to understand, hey, this thing isn't right, and then you can kind of go about fixing it. But I also think there's a lot of value for security professionals that are looking at high-risk applications or high-value applications that we need to secure, right? So if you're kind of in one of two camps, right? I don't know why this is looking so bad. Did I start the thing on fire? Oh my gosh. Okay, well, we'll keep going, we'll see what happens. Yeah, so two camps. Developers, if you're a developer or something, just keep this in mind. You can look through your code base the same way that a security engineer looks through their code base, and you can say, hey, that's not secure, let's get it fixed. And if you're a security engineer, you're someone that has a security mindset, you really want to target this type of effort on the high risk and high value applications, because it can be manually intensive, and so you want to put the effort where the effort is needed. All right, let's talk about our toolbox. These are the things that we will need in order to be successful if we are doing a secure code review. First things first, who here has heard of the OWASP Top 10? Fantastic. That is just about 100%. Okay, I won't spend too long on that. You know what it is, you know why it's here. We want to go through essentially everything on the list, but really if there is, depending on what your application is, you might target a couple, but you really want to lean into the tools that exist or the frameworks that exist to show you the vulnerabilities, to show you the bad things, and then you can kind of pick those things out in your application. So OWASP Top 10, same thing, OWASP API Top 10. If you know what the OWASP Top 10 is, then the API version of that is the OWASP API Top 10. Easy enough. Okay, So this is actually where I spend most of my time because a lot of the stuff that I work with is API driven. But if you have server-side rendered applications, back-end applications, or lower level IoT applications, you might feel a little more comfortable with the OWASP top 10 or maybe another ranking of vulnerabilities. The point is, you've got to know what you're looking for, and this is a good way to find out what you're looking for when it comes to vulnerabilities. One tool that I have in my toolbox as far as web testing goes is, of course, Burp Suite. I'm hoping that most of you have heard of that. This is not the only proxy tool that exists, and when you look at things like embedded hacking or back-end testing, when you're talking about network sniffing, that sort of stuff, there's a lot of other tools you can use. You're going to want to find the ones that are relevant for your specific application set. For me, Burp Suite is a great one. Finally, I'm going to list out a few things here. The cheat sheets, like I talked about before, they've got a lot of great technical information out there. There's a couple different hacking sites. The payload, all the fake site on GitHub is super nice, super friendly to just copy something, paste it into whatever tool you're using. It can give you a lot of great stuff. Hacktricks.xyz has tons of stuff, way more than you could ever possibly learn about pen testing, so really good to check that out. And then I bolded the last one because I think that from a business perspective, this is the most important one. When you are doing really anything in security, you need to be aligned with the business. And if the business says, hey, this thing you think is a security vulnerability is actually a feature, well, then you're not going to make any progress in terms of getting that fixed, right? So you need to understand what the business specifications are for the thing you're working on. If they say this thing needs to be exposed to the whole world for X, Y, and Z reason, okay, well then you're looking at mitigating controls around that feature. You're not looking to remove that openness altogether, right? So keep that in mind, that business specifications and leaning into what the business is doing is very important. Okay, last little bit of slide stuff before we'll get to real demo stuff. Framework, how are we going to approach a code base? How are we going to review it from a secure methodology? First things first, front-end functionality. We need to know what the website is supposed to be doing, what the website feels like, kind of click through and understand, hey, this is the rough kind of stuff we're dealing with. You know, you're going to look at a file upload manager a lot differently than you're going to look at a e-commerce shopping website, right? You might be hacking the file upload system and the file parsing system on one, and you might be hacking the cart and the payment system in the other, right? So it's really important to understand what the front-end functionality looks like. From there, you're going to take something that is a piece of front-end functionality and you're going to see where it goes into the code base through the inputs and the routing. So that'll be a little bit more clear as we go through the actual code, but inputs and routing is kind of step 2. Third, you're going to see the bugs surface within the code, right? And this might be that the specific thing you're looking for, the specific input is not being called where it should be, or it's being called where it's not supposed to be, it's not sanitized properly, right? There are tons and tons of different ways that this can look, so it's really hard to put a label on this, but essentially surfacing within the code, your thing, your input that you're looking for is going to surface somewhere, and it's not going to be how it's supposed to be. Finally, you want to consider your secondary impacts. Just because something is vulnerable doesn't make it significant, doesn't make it valuable to the business to fix, but if you can combine 16 different things that are slightly vulnerable but not valuable into one thing that's both vulnerable and valuable, that's how you're going to drive real change, that's how you're going to make an impact, and that's how the business is going to get more secure. Fantastic. Okay, we're done with the slides. We're talking about login SQL injection. So, for those of y'all that have not seen the Juice Shop application before, this is a vulnerable web application you run locally on your own computer. It's a juice shop, so it's a store. You click on stuff, you add it to your cart, you buy it. It's fake buying it, but this is what it looks like, and you're allowed to hack this. So if you want to get some more resources on that, I can help you find where it is, download it, hack on it. Great stuff. Unfortunately, if you didn't know what it was, you're now getting some spoilers. So I guess you can walk out the door now if you want. I won't be offended. We're going to go hack this thing real fast. So I'm going to go to the login functionality, and we are going to do something that's very simple, just a basic sanitization check, right? So we're looking for something that is reading in this special character. In this case, that's a single quote. And it's not handling it right. It's reading it as a piece of code rather than a string or just as a basic character. So if I press log in, we're gonna get this weird object thing. That's really hard to see, so sorry. Right here, just some red text. That's just an error message. Doesn't really mean anything, a little bit ugly, great, whatever. We're gonna have to head over to our network tab and see what went on underneath the surface. So we had our API call, and it looks like it went to rest/user/login. We had an internal service error, so we had a problem, right? Whatever we typed in, it didn't like, and we had an error. And the error we can see in greater detail here. And I guess I don't know if it's gonna be easier or more difficult to read if I highlight it. That is a SQL statement, and it's being returned to the front end. So we can already see some problems here. We've got some error handling issues. We can see a SQL statement clearly. That's pretty bad. But it looks like simply we have a basic SQL injection case. If you don't know what SQL injection is, feel free to write it down, go and research it later. But this is, one of the quintessential classic vulnerabilities that you're going to spot. And we're going to see not only that it is a vulnerability, but how it becomes a vulnerability in our code base. Okay, SQL injection, login. Let's go figure it out. First thing we need to do is we looked at the front-end functionality. Now we're going to look at our inputs and routing. This is a file called server.ts. Sorry, that's a little hard to read. It's a little fuzzy there, isn't it? Okay, it's a server.ts file. What does this do? This is where our APIs come in, they get routed to the right place, and they go out again. So we're not expecting any functionality here. All we're really expecting is to see our next step. I'm gonna put this down for a sec. All right, just gonna set this down. And we're gonna do a Control F for login, right? Right here. This is the thing we're looking for. Now, why is this the thing we're looking for? The /rest/user/login. Well, if we go back to our API call, we saw /rest/user/login. So really all we're doing is a direct search, direct compare. We saw it in the network tab. Okay, great. Now we're going to see it in the code base. Some code bases are a little harder to spot in terms of where the routing goes. You kind of have to fish around for it. This one is real easy. It makes it real simple on you. You got your endpoint, and then you got the thing that's going to happen. This login function here, that's the thing that's going to occur when you call the login API. It's just that simple. So I'm going to save you just a small step. If you were looking through this, you'd have to piece this together, but that login function comes from here. It's the /routes/login file, creates this login function, login object thing, and that thing's used. Funny enough, because I'm the one giving this presentation, I already have that pulled up, so that's pretty cool. And here it is. This is the login function. So now we get to figure out what went wrong, and we can see what happened. So this is the part where I'm going to start to add a little bit of interaction, a little bit of fun for the audience. I want y'all to put on your preschooler hat here, okay? So we're not trying to get really high level. This is not super technical. I want you to just look at this and just tell me some of the basic things you see, okay? It doesn't have to be security related. You may not understand the code base. That's okay. Just kind of shout out. Like, what are some things you're seeing? What are some things you're reading? User ID, fantastic, yes. We have user IDs here. I have no idea what that is yet, but I'm going to guess the developer knew what they were talking about, and that's going to be our user ID. What else do we have?
Looks like they're trapping all errors.
I'm so sorry?
They're trapping all errors.
Yes. Yes, indeed. They're catching errors, and then they're moving on.
They're setting up a security token for authentication.
There is a security token that's happening. Yes, absolutely. We've got the word authentication. We've got a token. I'm sure that has something to do here.
But your username should be an email.
Absolutely right. There could be a problem where we're not using the correct kind of username, or we could use a different username for more security. Absolutely. Associated session token with the user. Fantastic. Yes. Okay. This exercise is not to teach you that all these things are secure or insecure. All this is trying to do is help understand the code base, right? At this point, we're just trying to see what's here and trying to take what the code base has given us. So I'll tell you a couple more things I've seen. you've got all these comments here, this vuln code snippet. You can see it over here too. See it down here, right? These comments are everywhere. In the regular code base, you're probably not going to have comments telling you where all the vulnerabilities are, but in this one you do, that's pretty convenient for our sake. There's this verify post login challenges. Might want to take a little closer look at that. You see down here at the bottom, of course, this is our key thing we're going to get to in our second, our SQL injection. It's down there. But also just point out that this is TypeScript, right? So this is a particular language that's going to have a particular approach to the way that it solves problems. It might have particular flaws, CVEs, things that you can look into in greater detail. Every technology is going to have good and bad, so you can try and discover the bad or try and enforce the good. But anyways, let's dive into a couple quick things here. This verify post login challenges. This could very easily be just some process that takes place. Oh gosh, it's hovering over something.
You fixed it.
This very well could be some kind of process that occurs after you log in. Very simple, it's very innocuous. But it could also be something really, really bad. Like for instance, leaking all of the user passwords in plain text. This is the same verify. I guess it's the pre-login challenges. Excuse me. That's the pre-login. That's the post-login. Here's the pre-login. Okay, my bad. But anyways, that thing doesn't check for all these different passwords and then tells you actually if you solved a security challenge or not. So I don't know if I mentioned this at the beginning. The whole point of this website is that you can solve different challenges and then it throws up a little bit of confetti and it's happy that you hacked the thing and you found the right answer, right? In order to do that, it needs to have all the passwords for the things you're not supposed to be able to log into listed out here. Now they could be stored in a more secure way, or they could be encrypted or something. But in this instance, the authors put them in plain text. Now I don't blame them because this is intentionally vulnerable. But in a real environment, we could look at these and we could be very upset with our developers. We could start to work on a treatment plan and start to see about getting these removed. Now let's go take a look at the reason we're here to begin with. We've got this SQL statement. Can anybody tell me what is wrong with the SQL statement such that we have SQL injection?
It's not parameterized.
Absolutely, it's not parameterized. Now, is that the only problem, or is that just the main one? It's a question begging an answer. Even if it wasn't parameterized.
It doesn't validate the.
Absolutely. No sanitizing, no validation, nothing, right? You can just put a single quote in there and be on your way, right? That's a problem. There are many different ways to secure something. Some of them are better than others, right? Parameterization is definitely going to be the preferred mechanism here when we talk about SQL injection. But the reality is we have an insecure system, and this is exactly what it looks like, right? And it's really not hard to find. We only took a couple of steps through the code. It's right, big, and clear here, and it even showed us from the front end exactly what the line of code was that was so vulnerable. One thing I'm going to point out here as we kind of continue forward is this request.body, this object here. That's a thing that you're going to see a lot. And one thing we've already realized as we've begun this process is that thing is not being looked at too closely, right? That request dot whatever it is, request.body.email, request.body.password, they aren't checking that too carefully. And so that is a direct input from the front end to the back end that's not being checked carefully and that's being acted on by the code base. That is a place that is rife with vulnerabilities. I could just probably Control F for REQ dot and find tons and tons of different places where there's either vulnerable code or things that you could put in bad data and get bad results, right? That's exactly what a vulnerability looks like. So if we're doing this in a real code base, we're gonna mark that down. We're gonna look at that a lot more carefully, and every other API that we look through, that's gonna be our step one, is are they sanitizing that request? Are they properly validating the things that go in? And if they're not, what happens? What goes wrong? All right. So this is SQL injection. This is the first thing. We're done. We could all head home early. Hopefully y'all want to stick around for part 2. Scroll through my slides here. I have a list of things at the end that I think we've talked about most of these, but I'll just kind of briefly mention them again. We've got weird comments in the code. They tell us what vulnerabilities are existing. We've got plain text passwords. We're using TypeScript. We know kind of roughly what the routing and server files look like. None of this is telling us for sure what vulnerabilities are. I mean, I guess some of them are like plain text passwords. But once again, there's the concept of just going through a code base and trying to understand it better. And that's what a lot of this information gives us. And then we're also seeing vulnerabilities clear as day as well. So I'm going to give y'all a choice from here. We have two possible ways we could go with this. We have another vulnerability we could look at that's kind of multi-step. So you have to look into one file, then you have to look into another file, multiple places for failure, and it's a kind of a worse vulnerability than this one. Or we can skip the first step of looking at the front-end code, and we can just start reading code and see if we can uncover a vulnerability just by reading the code and not validating it on the front end first. Which one do we want? Number one, multi-step vulnerability. 2-3 hands, okay. Number two, looking through the code and digging that one up. Okay, we're gonna do this again. Hands up a little higher this time. Number one, multi-step vulnerability.
If we do the multi-step, we'll look at the front, but still look at the
Yes,
code.
yeah, so we're gonna tap it in on the front end, we're gonna see what happens, and we're gonna go into the back end. Okay, fantastic, and just look at the code first and figure out what the vulnerability is. Golly, this is very much a tie. I haven't had that happen yet. Okay, we'll just look at the first one. That one might be a little bit easier to understand for this purpose. Maybe go a little bit faster. And then that'll be about our time. So I guess I didn't really do this. This is how we exploit this vulnerability, right? If you go back to the code where this statement is, you can end the statement and then have a simple or 1 = 1. The statement evaluates to true, and you're on your way. This was kind of confusing to understand from you right at the beginning. If you don't know SQL injection very well, this is kind of your quintessential first way to make something go wrong. But essentially, this is going to let us log in, and that's pretty neat. So let's do it. We just logged in, and we are actually the administrative user. So that's the admin.juice shop. We can go to the profile and see the very weird looking picture that they put in place. Okay, fantastic. That's the vulnerability in action. Now, the next vulnerability that we're going to look at, oh my, this is going to require a little bit more work. So what we're going to do is we're going to add an item to our cart. We're going to see the API call that's made there. We're going to try to add a negative number of items to the cart, and then we're actually going to retrieve money from this store, which is pretty bad. Pretty bad news. Okay. So if I add an apple juice to the cart, there's this little thing at the bottom, probably pretty hard to read, but it says, hey, you add the apple juice to the cart. If I go to our network tab, there's all these requests. There's a get request to the basket, there's a get request to the basket items, there's a put request to the basket items. Basically a whole bunch of steps that are required for this thing to add this item to the cart. One of them, however, is the one that we care about. It's this put request. It's going to put the item into the cart for us. We can see the quantity is 3 that it wants to put in. Basket appears to be number 1. And then it says product ID successful. So we are going to take this request. We are going to basically copy it into our own Postman call, and this is going to allow us to hack this thing. So first things first, I need to get a valid token in here. If y'all don't know what I'm doing here, this is a process that basically allows me to not use Burp Suite. So Burp Suite is a web proxy. It would let me do all of these requests kind of in flow. I'd be able to click some buttons and do this really simply. I don't like to do that in these kind of settings because not everybody has access to those tools. Postman is a simple, free API tool. You can just copy it right from the network tab, put it into Postman. All good. You don't have to download hacking tools. No one has to get mad at you. Real simple. Okay, so let's try this. This has not worked for me before during presentations, so we'll see if this works. Success, yes, okay. We have now updated this product ID with the quantity 3. What if I make this -3? Is it going to let me do that? Of course it will, because I'm the one sitting up here. Okay, -3. So already we have a problem, right? We're not even looking at the code base yet, we know we have a problem. So we're missing an if statement, we're missing a check, we are not double checking that this thing is actually negative. But we're going to take this one step further, right? I'm going to make this -1000. And it lets me do it, okay? Quantity -1000. Let's head back over to the UI. This might be a little hard to see. I'm really hoping that it'll show off, okay? Right here, -1000. So whatever API we called, it worked. And we have a total price of -1900 currency, whatever that is. So far, this is little more than a novelty. If the checkout system doesn't accept this response, great, we can call this a medium to low flaw. The business will fix it in due time, and some people are gonna mess up their entry in their database because they'll have a negative number in there. However, all you need is one more thing to not quite work quite right, and you have a serious vulnerability. Just gonna go through a simple checkout flow here. I'm gonna choose a random delivery, doesn't really matter. All of this is fake. We're gonna use our wallet here. So I don't know if there would be any way to actually get money out of here, but we can put a bunch of money into our digital wallet, and if we click pay and then place our order, all of a sudden we have completed this with a total price that is negative, and very negative at that. Okay, zoom in on that. An almost -2000 of this currency that we've been able to obtain. That is a fundamental failure at multiple stages throughout this process, right? There were a lot of opportunities for us to validate this. There were a lot of opportunities for us to guarantee that this was going to work correctly, and it didn't. This could be across multiple teams in your environment. This could be across multiple tools or with a vendor that's not checking something correctly, right? This could be really hard to spot, but very importantly, really at any stage in the process, we could prevent this from happening. So let's go look through the code base, see what went wrong, and it kind of shows us, the simple stuff that we can do to fix it. Okay, so first things first, we're looking for this /API/basket-items/1. That's kind of the first thing we got to figure out. So let's do a Control F for API basket items. We've got this security is authorized. Now, I guess this is a pretty good simple teaching point. When you don't know a code base, you kind of have to rely on what's there. So in this instance, we see a security.isAuthorized check that is made. When you're looking at this, you might think to yourself, okay, now I need to dig into that to understand what that does. Maybe not. Maybe we can just trust that, hey, this security is authorized check. It's just checking that this person is authorized to make this call. We already know it's vulnerable, so let's skip over it. Let's say we think this is good and let's move on. And the reality is that we're going to figure out that that's really not a vulnerable spot in this code base. The vulnerable spot is somewhere else. It's actually down here in this basket items call. So if we head over to this, we're going to have to, scroll through. Once again, we're looking at our /routes file, and we're looking for our basket items.ts. Now you could go find this. I'm just kind of simplifying the process for the sake of this, but we have this call to quantity check before basket item update. We come down to quantity check before basket item update, and we can see how this works. So I'll save you all the audience participation this time and kind of walk through it. Same sort of thing before. We have this REQ dot. We think that, hey, maybe they're not properly sanitizing these requests. So this is going to clue us in that maybe something's wrong. We've got this basket item model, so that's maybe where our basket is coming from that we're going to add items to. And then we just check that there is a quantity. For those that don't code very much, this is literally just a, whoa, there you go. This is literally just a check that the quantity exists, not necessarily if that quantity is positive, negative, whatever it is. It's just there is a value there for the quantity, and then we perform a quantity check. So we're already going to have to go a step deeper. We go to quantity check, and then right here is the key line. So skipping over a lot of stuff, sorry. Happy to walk through this in greater detail with you after this if you'd like, but essentially you walk through all this, it does a bunch of stuff that really just gets you to the point where you check, is there enough in stock? That's the comment. Product.quantity is greater than or equal to quantity. So if you have enough items, well then you can give some of them to this person in exchange for money. But we do no check here that quantity is not negative. We don't do any check that quantity is greater than 0. That's bad. It's not that bad because in theory we shouldn't have a possibility to pay out somewhere else in the code, but hey, we got a problem here. So let's kind of keep walking through and see how this problem continues to manifest itself. So one vulnerability, but it's not the end of the world. Let's go to our network tab. We've got a bunch of socket calls. We've got this post to this checkout. And this information here is actually going to be, I do believe this is the API call, where the vulnerability really turns from kind of a novelty or just a missed if statement into something that is legitimately a vulnerability. So, same process again. You're probably getting sick of it. REST, basket, the number, and checkout. Let's go back to our server. We're going to look, I'm just going to type in the keyword checkout. REST, basket, the number, checkout. And then we have this order, and this is going to link probably to a /routes/order file. Sure enough, in this routes folder, we've got an order.ts. Okay, is this looking familiar? Is this is the exact same flow we just walked through a couple of times? Is this starting to feel pretty good, folks? This is exactly what I have done countless number of times in many different code bases. Once you know the general route that it takes through an API through a code base, it's just, you call an API, you track it through the code base, you see where stuff ends up, and you can kind of spot, hey, that's not sanitized, that's not checked properly, or hey, that's called in a bad way, right? The little things. In code bases, once you demystify a little bit, it's honestly a little underwhelming. It's a little like repetitive, like here's this vulnerability again and again and again. But this is what it looks like. This is the reality of vulnerabilities in a code base. Okay. Bring it home. Let's find the key line. So we've got our place order function here. I guess I wasn't calling out the functions before, so this is the thing we end up calling. It says place order function. We do a lot of stuff here. A lot of stuff. None of this is important to what we're talking about. One of the things that if you spend a lot of time looking at code, you'll get really good at it. It's just your eyes kind of glaze over at the stuff that doesn't matter, and you kind of tune back into the stuff that is really important. So we scrolled way down the page. We glazed over a lot of stuff that might be relevant later on, but for right now, we have a few key lines here. So we have our item price. It's a number set up here. We have our basket quantity. And then we have our product, which ends up just being the output. Our item price is multiplied by our basket quantity. Again, no check that our quantity is positive. No check that there's going to be a negative number output by this item total. That's it. We do a math.round and item bonus. I think that might be related to coupons. I don't remember for sure. And then we're done. This product ends up getting pushed down. You kind of move on into a bunch of other stuff, and then you end up solving the challenge negative order right here. The total price is less than 0, and that's really all there is to it. It looks a little boring in code, but the reality is that long ago, you sent a call for a negative input. That negative input was not properly checked. There was a missing if statement or an incomplete if statement. Then you move on, and then the next process, there's an arithmetic that thinks that everything's fine, right? Because the last thing is supposed to check it, and this one just does the math. In a previous time that I did this, somebody raised their hand and asked, is this really a vulnerable line of code? And the reality is it's not. If you check everything ahead of time, this is literally just doing the math. Right? Or if you check everything after the fact, again, this is just doing the math. But the way it stands now, this is really where the vulnerability is. This is really what ends up going wrong. This is what you call the surfacing in the code. So when we talk about chaining vulnerabilities, you can basically talk about one place where you had a missed validation, a missed input control that allowed something to be negative, and another place where you had an arithmetic that allowed that negative quantity to then turn into a really bad vulnerability where now you're paying out a bunch of money. Okay, that's basically it. That's that is how you look through and you find vulnerabilities. This is the general process. You want to understand the code base that you're looking through. You want to go down step by step. You kind of see what's happening on the front end. You look through routing. You find where the vulnerability surfaces, and then you look for secondary impacts. So I'm going to open up to questions. I can talk about other quirks and fun things about the code base, but that's it. Thank you.